Welcome back to the YouTube channel. Today we will be taking a look at the last and final part of algebraic expansion and factorization. And in this video we will be focusing on examples and how to solve the questions. So without any further ado, let's get started. Before we dive into the examples and questions, there is one special case that I have forgotten to mention in the previous video, which I will cover it now. This special case is where when you have terms such as a square minus b square, where both of the terms are perfect squares. It can be numbers or it can be terms, it can be unknowns. So we will see how do we solve this. So when you have a square minus b square, it's by default that the answer would be a plus b and a minus b. You might wonder, why is this the case? I will show you. If you try to expand this expression, you will end up with a times a squared, a times negative b, negative ab, and then b times a, which is positive ab. Then b times negative b, we will be left with negative b squared. So the negative ab in the middle, negative ab and positive ab will cancel out each other, and we'll be left with a square minus b square. This is why this special case will always yield back to this answer, which is ab and ab, but one with plus and one with minus. So it's important for you to understand this concept. Now that all the concepts covered in KSSM syllabus have been discussed, let's take a look at the questions. And this is the time where you as viewers are not just going to be looking at what I'm doing, you're going to do it together with me. Take a piece of paper, and the moment I display a question, please pause the video and try to do it yourself. If you can do it, make sure to watch through my working steps and check whether the answer is correct or wrong. And if you can't do it, no worries. Stop writing and then you can see how I'm doing it. And try to fill in your knowledge gaps so that you can understand it better. So the first question. 4 times b minus 1 in bracket squared minus 9. We're going to start off simple. This is quite easy, so I'll give you the time to do it. So I will be starting to show the answer in 5, 4, 3, 2, 1. Alright, so when you get a question, the first thing you have to do is observe the question well. Don't make the minor mistake of mistaking the negative sign for positive sign, mistaking the number, mistaking this 2 as an actual number instead of a squaring symbol. Please don't think that it's impossible to do that. I have seen people do that under stress. Stress can make you do wonders in the not so good way. So it's important for you to observe the question so that you are doing it correct. So first thing here, this is the only thing that we have that is we can do something to it, because you can't times a number directly with this, since this bracket itself is already in a squaring operation. So firstly, what you have to do is square the terms in the bracket. So this one is using the first method that we've learned about expansion, which is 4b minus 1 times b minus 1. So when you have squared, it just means that this entire bracket is times by itself. It is multiplied by itself. Just b minus 1, b minus 1. And then minus 9. Then here, firstly, it's better to take care of these brackets, multiply them first before going to the number 4. To the number 4. And then b minus 1, b minus 1. So 1 by 1. B times b. You will get b squared. b times -1, we will get negative b. -1 times b, we will have negative b. And -1 times -1, we will get positive 1. And minus 9. So first take care of the terms inside the bracket. What you have is b squared minus 2b plus 1 minus 9. I added this together, negative b and negative b. Negative b minus b, you will get negative 2b. And then for b squared, now what you can do is, you can expand it inside. We're trying all the possible ways to just put them all together. So now you'll have 4b squared minus 8b plus 4 minus 9. You'll notice that this is b squared, which is alone, you can't do anything about it. Then they have negative 8b, which is alone, you can't do anything about it. But you have 4 and 9 here, which can be that can be mashed up together. So plus 4 minus 9 will get you the answer of 4b squared minus 8b plus 4 minus 9 is negative 5. So that's the answer, because now we have one term with b squared, one term with b, and one term as a whole number. That's a whole number. That's all. So for this particular expression, 4 in bracket b minus 1 squared minus 9, the simplified version of it will be 4b squared minus 8b minus 5. That's all. So the moment you get the question, do not panic. The first step is do not get panic. First, read through the question, observe it well, analyze what can be done, and just start doing. That's the best advice I could give you for algebra. Just start doing. The moment you start doing, ideas will start to pop up and you will know the answer along the way. When you start algebraic question, it doesn't mean that you already know the final answer. No, it's as they say, it's a work in progress. You'll know the outcome while you're doing it, and until you reach the end, you won't know the final result. And once you reach the end, you'll know the final result. Just follow the steps, and you will be completely fine. So that's the first question. Moving on, we have our second question. Now we're adding in the mix of fractions, and let's see how you can do this. So again, 5 seconds. If you want to pause the video, feel free to pause the video. 5, 4, 3, 2, and 1. So here we have a fraction. And there's one important note that I would like to make sure that all of you understand. Although we are dealing with algebraic terms, although we're studying with unknowns, alphabets and everything, the basic concept that you learned in regards to fractions, addition, divide, plus and minus still applies. We are just adding the element of unknowns, the element of alphabets into already existing mathematical knowledge. Remember that. I have seen a lot of students make mistakes where just because of the introduction of algebraic terms and alphabets, they think that the rules of mathematics also change. No, maths still say the same. When you have to divide, still you're going to follow the exact same principles and everything. So make sure that you hone your foundational skills in mathematics very well, so that you don't face any problem arithmetic wise. So here, fractions, we follow the exact same concept, which is for fractions, if you want to add them together, the denominators must be correct. So for those who are wondering what's denominator, the numbers on top are known as numerators, and the numbers at the bottom are known as denominators. So the denominators have to be equal to each other in order for the numerators to be mashed up together. So as you can see, we have x plus y and 4 times x plus y. So the easiest way to make them both equal to each other is multiply this whole thing by 4. X plus y times 4, we will get 4 times x plus y. That's the goal here. So when you times 4 to the denominator, it's important to do the same to the numerator, because they are like one family And if you do a change to one of them, it's important and necessary for you to do the same change to the other members of the family. So you have x plus y and you multiply them by 4. Then you have 3 times 4. So the final the next step would be to write them out. So you will have 3 times 4, 12. And at the bottom, you will have 4x plus y minus 3z or 3z, depends on where you're from on Earth. And then 3z, and then down there you'll still have 4x plus y. So now as you can see, the denominators are the same. So when the denominators are the same, it's possible to write them as one singular fraction. So we'll have 12 minus 3z over 4x plus y. So once you have written the two terms into one singular fraction, that's it. This is the most simplified version of this particular expression. 12 minus 3z over 4 times x plus y in bracket. That's about it. As simple as that. The moment you start to see the patterns, I'm very sure you can understand how to apply it. Alright? So let's move on to the next question. We have question 3. So I'll give you time again, 5 seconds. If you want to pause the video, please pause the video, and your time starts now. 5, 4, 3, 2, and 1. And let's begin. So now we are again presented with a fraction question where we have 2 over r minus 2 plus 4 over 3s. The same rule applies. Equalize the denominator in a fraction question in order to combine both fractions into one singular fraction for you to conduct any addition, subtraction, division, not division actually, sorry, pardon me, for addition and subtraction. Alright, so here we have r minus 2 and 3s. The simplest way to equalize it is just times both of them by each other. As you see in the earlier question, it was much simpler because we just had to multiply 4. But here we are required to multiply by something completely different. So here, just keep it simple. Multiply r minus 2 by 3s, the whole thing. And then if bottom times 3s, top must also be multiplied by 3s. Then on the flip side, 3s times r minus 2, the whole thing. Then 4 times r minus 2. That's it. So here what we will have is, as for the numerator, we will have 3 times 2, 6, and s over 3s r minus 2, and then plus 4 times r we will have 4r, 4 times 2 we will have negative 8 over 3s times r we will have 3s times r minus 2 we will have 3s r minus 2. It is completely up to you if you would like to expand this part, but for the sake of simplicity I will keep it in this form for a while. Then now that the denominators are the same, it's wise to put them together for easier handling. So 6s plus 4r minus 8 divided by 3s r minus 2. I have always been asked this question whether we have to expand this or not. The answers that have been given to me by my teachers was mainly it's alright if you would like to do so, but it's not a problem if you don't do it as well. So what I have concluded from this is it's better to just do it, because they want you to give a simplified version with no brackets. So just put no brackets there. So you will have 6s plus 4r minus 8 divided by 3rs minus 6s. And as you can see, now we have 6 for 8, 3 and 6. There is no common denominators to divide from both sides, on both top and bottom. So we can just leave it as it is. And that's all for question 3. Now moving on to question 4. And your time starts now. 1, 2, 3, 4, 5. You may notice that I counted from the other way around. It's just for fun. No particular reason. And so question 4. Here, what we can do is the same thing, equalize the denominator. By equalizing the denominator, I mean we have to make these two the same. So as I told you earlier, you can of course times the whole thing by 6m squared, 6m squared, and then times 3mn and times 3mn. It's possible, but there's also a better way to do it. All that's possible, the number that you will get at the end will be quite large, and you have to simplify at the end as well. So what I would like to do is, I will see the numbers and the alphabets separately instead of together. So you have 3 and 6. So for 3 to become 6, we have to times it by 2. So times 2. Then times 1 here. So there's no need to put 1 there. So times 2. And then there's 1 m here and there's 2 m's here. So there has to be another m right about here. So times 2m. Then there's no need to change anything over here. Then we have n. But n is already available here but not here. So we have to times this by n. So if you take a closer look, what we have done here is we have found the HCF for both of these terms through deduction. So when you try to multiply this with what we have found here, 3mn times 2m, we will get 6m squared n, and 6m squared n times n, we will have 6m squared n as well. So we have managed to find the highest common factor for both. And this is a very useful thing to do in exams if you're running out of time and you have to do a question faster. So when you multiply a denominator by a particular term, it's important for you to repeat the same thing for the numerator of that respective denominator. So 3 times 2m as well. Then over here we have n times n. So as the final result, we will get 3 times 2m, which is 6m, plus, over 6m over 6mn squared. Pardon me again, m squared n. Mistakes do happen, and it's important for you to correct the mistakes. 6m squared n. And plus n times n, we get n squared over 6m squared times n, we will have 6m squared n. So now that the denominators are equal to each other, we can put them together. 6m plus n squared over 6m squared n. This is what we have as the final result from this particular expression. 6m plus n squared over 6m squared over m squared n. That's it. Moving on to the next question. Question 5. Same thing. Time given will be 5 seconds. 5, 4, 3, 2, 1. Now we have got to a very interesting part of algebraic expansion that I love. Algebraic expansion and factorization. This is the part that I love because although the answer is apparent, it's kind of like shrouded in mystery. We have to take it apart like a puzzle. And that's a very important mindset to have. When you're trying to solve algebraic questions, or any questions in mathematics for that matter, it's important to take a look at it as though it's a puzzle rather than a mind-numbing challenge. It's a challenge for you to see what is actually possible. So when you have m plus n over m squared minus n squared, what is the first thing that comes to your mind? First thing is a lot of alphabets and no numbers. True, but apart from that, you can notice what we have learned in the past playing a role here. We have m squared minus n squared. So this is something that I reviewed in this video, so that I hope that you still remember it. There was a concept that a squared minus b squared, the answer will always be a plus b and a minus b. Why is that necessary? We do not know, we just have to do it. This is what we call trust the process. So we have m plus n at the bottom, at the top, and we can't do anything about it. M plus n is the most simplified version. There's nothing that can be done. So we will have m squared minus n squared. When we factorize it, we will have m plus n and m minus n. So you might wonder, what can we do with that? Pay closer attention. You have m plus n and m plus n. So you can eliminate them by the process of elimination, and you will have 1 at the top, because 1 times m plus n is m plus n, 1. And at the bottom, you will have m minus n. That's about it. As simple as that. So what the mindset that I have when I'm starting to do algebraic question is this: let's just have fun and find every single factorization possible. So when you have that mindset, you are just having fun and just going through each and every part of the question, trying to factorize it to the most basic form of it, so that it's easier for you to mix and match, divide this by that, cut this, cut that, eliminate this and that. So just have everything at your disposal by factorizing all of the fractions, or all of the terms, all of the expressions that are given, by breaking them down to their finest bits. It's easier for you to mix and match and make sense of it. So I hope you understand the concept and the mindset that you should have when you are trying to tackle a question, mathematical question, any sort. It's very important to see it as a puzzle. Puzzle mind is very important. So moving on, we have the next question, question 6. And now we're getting into the big guns. The last question will be quite tough ones, because we're going to incorporate all of the knowledge that we have learned. So here, I'll give you 5 seconds. Please pause the video if you would like to give it a try, and I highly recommend you to try to give it a try. Please give it a try. So 5, 4, 3, 2, 1. All right. So the same concept applies. This is a fraction. This is a division fraction. Remember, this is not addition or subtraction, which require the denominators to be equal. For divide and multiply, you don't have to have equal denominators. I'd like to make myself clear. For addition and subtraction, you need the denominators to be the same, so that you can put the numerators together in a single expression, in a singular fraction. But for divide and times, you don't have to do that. You just have to straight away multiply them or divide them. All right. So what we have learned in elementary school is, when we have divide, the second term on this part will go through a flip. The top will go to the bottom, and the bottom will go to the top. This happens while the divide sign is changed into multiplication. This same concept still applies. There is no secondary school magic or whatsoever that you're going to learn about division in fractions. Just remember to flip the second term while changing the division symbol to multiplication symbol. All right. So I'm doing that because this is a conceptual understanding that is stemmed from primary school, and I hope that you remember this. 4t squared minus 1 times 4t squared plus 4t plus 1 over s squared minus u squared. So once you have this fundamental breakdown of division into times, now it's just simple. So now the goal is to simplify it as much as you can so that you have all the liberty to mix and match things here and there. So take a look at it as 4 different puzzles. So first thing, STN plus TU. What can you take out from it? Can you factorize it? Can you expand it? There's no expansion because there's no bracket. So the expansion is out of the table, is off the table. So what we have to think is in terms of factorization. So ST and TU, what is common in both? We have T. So we take out T. Then we are left with S plus U. That's it for the first puzzle. Second puzzle, we have 4t squared minus 1. To the untrained eye, it might look as though it's the simplest form. But make sure you train your eyes. 4 is the square of 2. T squared is the square root of t, which is t squared. Then 1 is the square of 1. So this is a perfect square. It's just the same concept as a squared minus b squared. So what happens here is 4t squared becomes 2t. Then 1 becomes just 1. So 2t plus 1 and 2t minus 1. See how subtle that is? It's very subtle. Then we have 4t squared plus 4t plus 1. This is where we have 3 terms and there is no common factor in all of them because there's t in the first 2 but there's no t at the last one. So what you have to do here is, when you have 3 numbers, remember it's a cross method. So what times what gets you 4t squared? So if you remember the cross method, we will have 3 columns. We will have 3 columns right about 1, 2, 3, 4, 5, 6. We have 3 columns. And in those 3 columns, put the line over here. And then the first part is 2t, 2t. You will have 2t times 2t because 2 times 2 is 4 and t times t is t squared. You have 4t squared. And then we will have 1 times 1 because that's the only way you can get positive 1. There are only 2 ways, negative 1 times negative 1 and 1 times 1. Since the number in the middle has positive, let's try positive numbers first before diving into negative numbers. So 1 and 1. So if you put 1 right here and 1 right here, remember it's positive. Then 1 times 1 you'll get 1, and then if you just have to cross multiply, and then you will get 2t here, positive 2t and positive 2t. When you add them up, you get positive 4t, which corresponds to the number in the middle, to the term in the middle. So now we know this is the correct variation. So the answer is 2t plus 1 times 2t plus 1. I hope you understood that bit of working step. If you can't understand it, I recommend you to watch that part one more time. If you still can't get it, head over to the previous video, part 2, where I discussed this concept in a slightly better detail. And if you still can't understand, be sure to send me an email. I will be responding to you as soon as I can. So what we have here is 2t plus 1 times 2t plus 1. Right, this is the factorized form of these 3 terms. And finally, we have s squared minus u squared. Both are squared, perfect squares, so we can use the a squared minus b squared concept, where we will get 6 plus u multiplied by 6 minus u. And that's it. We are done with factorizing. Now what you have to do is just mix and match. So here, remember this very important thing. You can eliminate or you can cut similar same terms which are similar to each other, which are same to each other, up and down a fraction and crossways in a fraction. Remember this. It's always in this form. Up and down, bottom left, top right, top left, bottom right, bottom right, correct. So this is the X of mathematics that I would like to call it. It's not X, it's more like a ribbon. But never mind, just remember this so that you know how to cut and whether it's quite to cut or not. You can't cut directly, by the way. This is just for multiplication. Alright, so what you have to do now is start cutting. So we firstly s plus u and s plus u right over here and s plus u right over here. Just cut them both. 1 and 1. Then 2t plus 1 here, 2t plus 1 here. Just cut them both. So what you're left with is, at top you have t times 2t plus 1 over 2t minus 1 times s minus u. So as you can see, there's no further cutting possible. So this is the final answer. So I would highly recommend you just expand it so that you don't have any confusion after passing out the paper. So at top you'll have 2t squared plus t over 1 by 1 2t times s, you get 2st. 2t times negative u, you get minus 2tu, and then negative 1 times s, you get negative s, and negative 1 times minus u, you get times negative u, you get plus u. That's about it. And that's the simplified version of this. I know that this might seem a bit lengthier compared to this, but this is from what I think is the safest method. So that when you expand everything, there's no more bracket, so it is a simplified form. But it's also important for you to ask your teachers on which one do they prefer. Some may prefer this and some prefer this. It depends on your teacher, and make sure you discuss about this with them in order for you to be confident in doing your exam. And then that brings us to our last question, question 7. And this question is not an algebraic question in the form of numbers or alphabets. It's more of a exam type question. So I'll give you 5 seconds. Please pause the video to give it a try. This is an interesting question. 5, 4, 3, 2, 1. Alright, let's see how to do this question. So I have a habit of drawing out every single word question so that it's easier for comprehension. So Azima makes a square layered cake. So the first key information is squared. So let's put square. Let's put a square. Do not think that I have a very good drawing skill. It's just that Notability makes drawing much easier. Square layered cake measuring 3x plus 2 centimeter long, 3x plus 2 centimeter long, and x plus 2 centimeter wide. It's important to note that all of the sides have the exact same length. And then she cuts the cake into 6 equal parts along the length. So let me rearrange this for better visualization. So this is the length and this is the width. So she cuts the cake into 6 equal parts along the length. So there are 6 cuts in this region. Oh, the equal parts are 6 and 3. I think I should have made it into 6 times 6 squared. No worries. I can change it right about now. 1, 2, 3, 6. 1, 2, 3, 4, 5, 6. Okay, just bear with me for a second. I'm making it so that it's easier to visualize. now that we have this one, let's move on. So it is said that along the length it's cut into 6 equal parts. So 6 equal parts as in 1. I think I better use the color red. 1, 2, 3, 4, 5. 5 cuts, but as you can see, we have 6 parts here. 1, 2, 3, 4, 5, 6. Okay, that's along the length. Now, along the width, 3 equal parts. So this will be, I will use the orange color. Let's cut some kind of dark orange. So 3 equal parts, we have 1, 2. So we have 1, 2, 3. 3 equal parts. 3 equal parts mean 1, 2, and 3 equal parts. So determine the area of each piece of cake in the form of algebraic expression. Now they want the area. So technically all of the parts are the same value, are of the same area because we have cut them equally. So they are asking to find the area, which means this section times this section. That's it. As simple as that. So since we have a visual explanation of how to do it, it's very easy. So this has been cut into 6 parts. So which technically means 3x plus 2 divided by 6 multiplied, this is the length, then the width will be x plus 2 divided by the number 3. So x plus 2 divided by 3. This is how simple mathematics get the moment you understand it. So that's about it. So what you have to do now is just multiply both of this together. So you will get 3x plus 2 in bracket and then x plus 2. And at the bottom you will have 6 times 3. Remember, it's not addition or subtraction which requires the denominators to be equal. This multiplication just times them together. And here you will get 3x times x, 3x squared, 3x times 2, 6x, 2 times x, 2x, and 2 times 2, 4. Then we have 18 at the bottom, equals to 6x plus 2x, you will get 8x. So which will equal to 3x squared plus 8x plus 4 divided by 18. And that's about it. This is the area of one piece of cake after being cut into 6 equal parts along the length and 3 equal parts along the width. And there's one important thing that you should add in here, which is the metric unit centimeter squared. This is very important in exams. If you do not put this, you might lose marks. And that brings us to the end of the video. I hope this was useful. And if you do not understand any concepts, please email it to me or put in the comments below so that I can take a look at them and produce another video answering your questions. But that's the official end to the 3-part series we have for this chapter, Algebraic Expansion and Factorisation. So hope to see you in the next one. Till then, bye bye.